Hey there, welcome to Heavy Networking, your podcast for all things networking since 2010. If the words spanning tree make you cringe and capacity planning perhaps make you happy, well, you found your tribe. I'm your host today, Ethan Banks. My co host, Drew Conry Murray, is out of the office on vacation and should be back next week. Please follow the both of us on LinkedIn. We'd appreciate that. Danny Wade is here to discuss network testing with us. Danny's a network automation practice lead at Blue Ally and gave a talk at AutoCon 2. AutoCon is the twice-a-year network automation conference put on by the Network Automation Forum, and Danny's AutoCon 2 talk was on network testing. And if you want to watch that talk, you can. It's up on YouTube. Just go find it. Now, Danny's talk really grabbed my attention because it put a lot of pieces together for me. And by the way, Danny's also the co-author of the Cisco Press book, Cisco PyATS Network Test and Automation Solution, along with John Capobianco. And John, you've heard on Heavy Networking before. So Danny, welcome to Heavy Networking. And man, I am definitely looking forward to picking your brain about network testing, how it's a part of a network automation practice, and so on. But before we get to that, as far as I know, this is your first time on Heavy Networking, right?
Hey, Ethan. Yeah, absolutely. First time, long time listener.
Okay.
So I definitely appreciate you inviting me on.
Well, tell people briefly then who you are and what you do.
Yeah, so my name's Danny Wade. I work at Blue Owl. I'm a network automation practice lead. So I guess to decipher that a little bit. So practice lead really spans across the whole business, right? So I'm part of kind of pre-sales engagements. I help with kind of connecting our engineers with the solutions being sold, and then ultimately helping on the delivery side as well. So kind of get to see the whole life cycle of our automation services. So if you ever have a question about any sort of services we offer, I'll be the guy to talk to.
Cool. When I was in the consulting world, that was I worked at a consultancy where the model was pretty similar. I would be on the pre-sales side, kind of understanding the customer's challenges and what they were looking for, working with the sales folks to help design and deliver that solution, what that was going to be, and then on the back end, actually doing a lot of the implementation too. So, like you, got to see the life cycle of it and appreciated that because man, I've also had been part of some orgs where it was the other way, where someone else would design it and sell it, and then you'd get handed to it, say, "Go implement this," and that was just like, "You sold them what? Oh no, that's not good. I gotta implement that. I don't wanna." So it was always great to be on the front end of the sales process.
Yep, and that's exactly what I'm there to do. And I, like you said, I want to avoid the situations as much as possible. So I find it almost a nice challenge of wait, some of our engineers are asking, hey, what are we selling again? And then the salespeople are asking, wait, how are we delivering this again?
Yeah,
Being that glue between the both, it's actually a really fun challenge. So I really like
yeah,
what I do.
yeah. Now, in your spare time, somehow you found time to co-author a book with John Capobianco there. So please engage in an act of shameless self-promotion and tell us about this book.
Yeah, so John and I connected virtually, ooh, maybe 5 years ago now. Got back and forth on Twitter at the time. We both had a general interest with Cisco PyATS, and John was at Cisco at the time. He got the opportunity to begin, authoring a book about Cisco PyATS because there really wasn't one. There really wasn't one out there, and it was very underrepresented. In both of our opinions, it was underrepresented. Cisco didn't do a great job advertising it, marketing it, but at the end of the day, John got the opportunity to, put in a bid with Pearson or a proposal and get it written. So he brought me on board, which I'm very thankful for. And so, yeah, it took us about a year and a half to, writing, editing, and getting it off the ground. But yeah, it was a great experience. It was my first book. I think it was John's second book. He independently authored one about Ansible and network automation few years back. But this is like the first one, between both of us. So first Cisco Press book between both of us. So it was it was a fun experience, and yeah, it was great working with John.
Okay, the book starts with Cisco Pi ATS and in the title, and it's a Cisco Press book. So does that mean I have to be running a Cisco network to get value out of this thing?
Great question. No, you don't. Many people think it is a Cisco only tool. It was, to give a little backstory, it was developed within Cisco and used to test Cisco software. You think iOS, iOS XE. And so, there's a lot of obviously very network focused design around, but at the end of the day, it is a kind of an open testing framework, right? So there is a library for just the parsers alone, and those parsers stretch beyond Cisco. And it's actually an open source where you can contribute parsers for your particular network device of interest. So, if, for example, Nokia, there's some SROS parsers. Juniper has some Junos parsers as well. So the testing framework and the parsers, like I said, are I would say vendor agnostic to put it simple.
Okay, so I go after this book if I'm interested in network testing specifically. That's my focus. In other words, it's not a volume on network automation broadly. It's really leaning into the network testing component of network automation.
Correct. Yep. It's not just another Cisco book. It's not one that's going to tell you how Cisco does it or how the particular Cisco platform does it. Obviously, it will take a nod at some of the development that happened within Cisco, and there's some particular features that are, work more nicely with Cisco network devices. But at the end of the day, it's agnostic in that it is purpose built for the network.
Okay. No, well, let's get into our conversation about network testing then. I mean, obviously, you co-authored a book, you've been doing presentations. This is a big part of your world. Maybe the right place to start is why network testing? What am I accomplishing here?
Yeah, so I think it's good to kind of start with where people, when you hear network automation, the big term, everyone thinks about deploying configuration as, the number one primary use case. And a lot of times it is the primary use case because no one thinks about automating until they have to, or unless, obviously if you have an interest in it, that's a whole other conversation. But automation doesn't come really until there's a deadline set and something needs to be completed. And so with that, network configuration and configuration management become a top priority. However, if you're trying to adopt network automation into your enterprise or you're trying to learn it on your own, the way and how everyone kind of makes this decision of learning is keeping the risk at a minimum, right? So with network testing, that allows you to work on your automation skills and also learn a lot about your network without worrying about, oh no, I'm gonna send out this breaking change and destroy half my network or make some routers unreachable because I had a fat finger or my programming logic wasn't exactly up to par, right? So the network testing is really, I think, where everyone should start with network automation, from learning programming and learning the kind of the automation bits of it, but also from an adoption perspective. Whether your company is, maybe programming, some automation, but you're trying to get it adopted and trying to get up and running, at your company. I think really network testing is where you should begin. There's a lot of valuable data there, and you really have minimal risk when it comes to execution.
Yeah, low risk in the sense that we're not driving changes. We're testing things, we're gathering network state, we're doing comparisons, we're checking diffs maybe. We're doing that sort of work that is gathering data from the network, looking at it, doing something, doing some operations against it, but not necessarily pushing a change.
That's exactly right.
Okay, okay. Now, when we get into the discussion of testing here, there's a bunch of different types of testing, which I admit from time to time I get a little lost in these conversations because there's all these different types of testing that if I was a developer full time, maybe I'd know exactly what those terms meant. But even though I have a programming background, not really the world I've been in. So, in your presentation, you mentioned at least these four: unit testing, integration testing, end to end testing, and regression testing as different things that we might care about as network engineers. Can you walk us through these different terms, what they mean, and maybe give some examples along the way so we can kind of figure out how they're different from one another?
Yeah, so I'll start by saying all these different names of the testing that you just ran through. They all come from software development, right? And so these tried and true have been around for a very long time. So it's not something new that, network automation just made up, right? The practice of network automation made up. This is starting to more think in that software developer mindset, which we really have to start thinking about when you start transitioning into network automation and really full-time network automation, right? So kind of start out, you mentioned, unit testing. So unit testing in programming is like testing a method or a function. But in the networking side, I kind of view unit testing as running tests that are pertinent for a single device. So if you take just one device by itself, let's say you want to check all the interfaces and you want to check the interface descriptions for whatever reason, right? Or the interface status. You're doing this um, and it's local to the device, right? So whether you make the idea is whether you make changes, outside of this device, outside of the device, really it doesn't matter in the context of unit tests. Unit tests are very localized, testing on the device.
So, what is the unit itself referring to? Like you mentioned, we're referring to pertaining to a single device. Okay. Is the device the unit, or is like the chunk of code or the function the unit?
The device. So in the context of software development, it's normally the function because at the end of the day, the function is the entity, right? But as far as network
Hmm.
automation is concerned, it's that router, the switch is the unit. That's kind of
Got
the way I view it. You may have software developers come and say, "Hey, actually, no, that's not the case." But as far as trying to bridge the gap between software development and networking, when we're talking about unit testing, we're actually testing testing settings, configuration options, operational state of a particular device, and it's very localized to that device.
Can you give an example?
Yeah. So, I mentioned like interfaces, interface descriptions, but maybe you're looking at something like routing table, or you're looking at ARP, or you're looking at any sort of operational data. Think of if you're from the Cisco or Arista world, a show command may pull out that's
Hmm.
local to that device. That if out of context, that data wouldn't be relevant to any other device. So it's very, like I said, localized, and the checks can depend. The tests can depend on your particular environment. But yeah, a lot of you can even do looking at environmental variables such as temperature. Are the fans
Mm.
operating? Or you're starting to blend into kind of the traditional monitoring space
Okay.
at that point, but you're being very yeah, it's just localized to that particular device, making sure that that device meets your expectation.
So it could be a unit. A unit test could be, I see all the OSPF neighbors I expect to see. Would that qualify?
Yeah, yeah. I mean that could be one. And from the perspective of that device. Yep,
From the perspective of that device, right? Yeah. I mean,
correct. Yeah,
obviously, if we're talking about a routing protocol, there's a whole bunch of devices that are involved in that, and so on. But if I'm running that test locally on that device and I'm expecting to see 10 neighbors and 10 neighbors appear, then
right,
that unit test is passed. Okay. And
right.
then you mentioned things that are very practical, like environmental kind of stuff. Yeah, I could read temperature sensor readings, and the device is not too hot. The fans are not going 1,000 miles an hour, whatever it is that I might care about for a million reasons. But again,
Right.
the key here, unit testing local to that specific network device. Okay. What was the next one, Danny? Integration testing? Is that where we go next?
Yeah, integration testing, and that actually, you mentioned OSPF and looking at like neighbor tables and figuring out maybe neighbor state as well. That kind of bleeds into integration testing. So integration testing is we're looking at multiple devices, maybe looking at multiple neighbors of that one device, and we're validating that. You know, hey, I see these neighbors are in this state on this device. Let me look at the other device and make sure that adjacency makes sense on the other device and there's no problems happening there. So you're starting to, as the name suggests, integrate with other systems, right? So in the software world, you introduce, we're going from that one function in the unit test and we're now incorporating that in more of other functions with other modules. That's kind of what integration testing means on the software development side. But with network testing, now you're starting to integrate that one network device with other network devices. And so being able to view the data across multiple devices and then validating that data, multiple sets of data, right, across these different devices.
if I do a BGP policy that causes a route to appear or not based on a certain condition on one device, I could check a different device to see that the route has actually appeared or disappeared, as the case may be.
Right. That's yeah, that's a great example.
Okay.
Because if you did a unit test on each of these devices, you could now if you were looking for what that particular route on each device as part of like a unit test, then you could probably, get see that that test would fail. But sometimes you don't really see the problem until you get the bigger picture. And that's kind of
Yeah.
where the integration testing happens, where you're looking
Got it.
across multiple devices.
Do you have more examples offhand?
The routing policy probably is a really good example of yeah, because that's something that will change depending on other connect your other, when you're looking at multiple devices at once, you see that full picture. Whereas if you're
Hmm.
doing each individual device, you may not see that route. So I mean, yeah, normally normally like routing is that go-to example.
Yeah. Okay.
Because
Okay.
that's where, yeah, that's how, you can look at from a switching level. You may look at like MAC address tables. You could look at
Yeah.
because obviously you can do MACsec, and there's some additional things like port security is another one that you could that would be maybe a little more unit testing, but yeah, it's routing is normally a good integration testing point because that's starting to branch out beyond just that one device.
All right. So unit testing, integration testing, we've covered so far. A next one that you had mentioned was end-to-end testing.
Right. So end-to-end testing, this one is one that I think every network engineer can relate to. This is where your pings, your trace routes, uh, using tools like iPerf for
Hmm.
performance testing. That's where kind of these tools and come in handy because now what you're doing with the end-to-end testing, you may, from a network engineering perspective, I can imagine some listeners may think, well, why wouldn't you just do that? Like then we know like unit testing, integration testing, all that stuff probably works. Um, you absolutely could, right? And there is like there is a hierarchy here, but the thing with software development and why there's these different levels is because there's constant iteration, right? And that's very different than what network engineers are used to today. We're now I think just hitting the age of we've heard the terms net DevOps and being able to CI/CD pipelines, right? And incorporating some of these software development, lessons and things that we're learning from principles, we're incorporating that into networking today. So the reason there are these different levels of testing is because there's constant iteration within software development that we don't traditionally have in networking.
Yeah, because we don't want to keep changing. We don't want to move fast and break things in our
Right.
world. No, we want to
Right.
move slow and carefully and thoughtfully. But
Almost like
if
you
we
need it.
begin, well, if we go through the process of developing a change and moving it through a pipeline and so on, there's a whole process to it that when we actually push that change into production, we have a high degree of confidence that it's going to work, as opposed to some software development that maybe is less of that, or at least software development's kind of gotten a reputation for being less robust in its in the way production code comes to life.
Yeah, it's almost wouldn't it be nice if we could just automate the testing of some of these changes? That's what we're talking about today.
Yeah, yeah. There we go. Okay. Okay, so end-to-end testing is like you said, what everybody and so in this from a standpoint of network automation, and if I want to do an end-to-end test, it's not some oddball thing I've never thought of before. I'm summoning a familiar tool like a ping or a trace router or iPerf that I've been using forever and just incorporating the results of that in a more structured way that code can digest and understand what just happened.
Absolutely. Yeah, no, that's exactly what it is. Because as just like thinking that, the OSI model, if you're able to ping across, there's got to be a lot of things that are already in place. And
Mm.
so that end-to-end testing kind of covers unit testing, integration testing, that should have already been done. And now we're looking at the whole path.
Okay. The last one was regression testing, and regression sounds like we're going backwards in some way. Am I on the right track?
Yeah, yeah, you're spot on. So regression testing, this is one that would be definitely new to. It's it's n- it's one that's very interesting because so with software development, Um, when you have constant iteration, there's a more likelihood that you're going to run into bugs or issues along the way, right? And so, just as with any code development, when you constantly, you're writing code to change the network or pushing changes, um, you want to make sure that something that you just introduced, a new change, right, and switching context to network engineering. Hey, I put in that one line of config. It probably shouldn't do anything. So can I push it, this Friday
Mm.
afternoon? That last like it shouldn't do anything, right? And let's say it does, right? Something goes down, you're working the whole weekend. Finding that one little line of code that you thought didn't really make a difference that ended up being a cascading effect, that's figuring out that little code, that little piece of code doesn't break anything, that's regression testing in a nutshell.
It's proving. So how is that? Okay. Mm, I need more help to differentiate that from unit or integration testing. Then.
Yep. Yeah. So with regression testing, let's say you put in a new feature for a device or new configuration. Let's say you want to enable port security. That's a good one. Let's say we
Sure.
want to enable port security on a switch, right? We enable it, a lot of things break, right? We run all of our suite of, basically think of it as regression testing assumes that there's already some tests that are already being run against the network or against, your software. So you run those tests, everything looks good, everything passes. You start writing some code and
Well,
you
okay. So regret just to amplify that, regression testing assumes there's already tests being run, as in probably unit and integration tests.
Correct. Yes. Sorry.
Okay.
Yep. Unit integration tests are already being run. Things are passing because the idea with this is each of these different tests they run every time in like a. I'll try to bounce between the software development and the networking side and relate to both. The software side, you're constantly running these tests every time you commit code, right, to a code base. So every time you think, okay, I got my code, it looks good, I'm going to push that code into the main repository. Think of GitHub or GitLab. um, you can have pipelines, CI/CD pipelines that run these tests automatically and report back. Yep, green check, everything looks good, or hey, red X on this particular test. So from a networking side, everyone has those SOPs that when you push out a change, you have a change plan, a backout plan, and then a validation plan. That validation plan, a lot of times you do also pre-checks, right? So you run those pre-checks. You may run the same exact commands, pre-checks and post-check, or app, sorry, pre-change and post-change. You'll run the same checks there, but you'll understand pre-change, everything looks good as expected. Post-change, you recognize, oh wait, things don't look right or some things are working, but others aren't.
Mhm.
And that's where regression testing comes in, right? As soon as you put in that new change and you start seeing things that break, you're validating that whatever config is out there was working before the change and it's working after the change, things that are already in place.
Okay. I think I'm starting to get it. Yeah. It is it's a subtle. There are subtleties, and there is some
There is.
overlap in these different forms of testing, and so trying to put them each in a clean box, which is what I was trying to do initially, I'm finding isn't quite the right way to think about this.
Yeah, and it definitely could be me too, not explaining it really well, but I'm trying to relate it back to networking, which can be difficult. But the idea is regression testing is making sure that whatever code or config you have in place isn't broken by any new configure code that you're putting in as part of a change. So maybe
Ah.
think of it as, yeah, and that's probably where I was off. So the past 5 minutes you probably can scrap.
No,
Because
this was good. This was good progress. We got there in the end, and all those words now fit together. I get it. So that was good. No, we don't want to cut that. That was a good journey to go down to get there.
correct. Yeah, so everything that's in place, anything new shouldn't break what's already present.
Okay.
That's the
Okay.
best way to put it,
Got
more
it. Got it. And then
concisely.
the word regression makes more sense when you put it that way, because
Correct.
it's that look backwards, if you will, at the code that already exists and making sure the new stuff didn't just clobber it in some way. Okay.
Exactly.
All right, so unit testing, integration testing, end-to-end testing, and regression testing. And you've given some examples along the way. Uh, but let's put it into a NetOps workflow. How do these different types of testing fit into my workflow? So for example, you led off this podcast saying that network testing doesn't always have to be tied to a network change necessarily, or you don't even want it to be that way because it's testing by itself is low risk and it's a good way to get started with automation without pushing changes. Okay, so how do I think about creating these sorts of tests and plugging them into my workflow so that they're part of my day to day?
The first thing I would say is think about when things, let's say you have a problem that pops up, a network issue, and I know that can range greatly, but what are some things, what are some commands, what are some places you look at to begin troubleshooting, right? Are there your go-to show commands, or do you log into particular systems? Any of those initial troubleshooting, like, hey, I have my list of commands I run, those are very good candidates for running or creating these test cases, as you know, as they be called, because you know innately as a network engineer what these outputs, what these values should look like, right? So I know for a fact my core routers should look like this. My my switches should be running this, or and it could be very particular numbers like or number of routes, for example. Maybe you're so ingrained in that router that you know for a fact all your WAN routers should run X number or have X number of routes or X number of routes to a particular prefix. But you could even look at some things such as spanning tree, right? Like given a snapshot of the network, you can quickly figure out, where's root, what are the forwarding ports, and that sort of deal with testing, right? It's not something that's in your head. So what network testing can do in that situation is you can take basically a snapshot of the network and validate all of those particular values out of the box and be able to compare them. More importantly, compare them from the day before, a week before, and see progression over time.
Well, this would be in the form of, say a Python script. I mean, you think in terms of Python, I imagine, just based on the
Right.
book you wrote and so on. So I write a Python script that does data gathering, stores it in a database somewhere in some kind of a format that where I can retrieve it and see it over time, and then I can do another script that maybe does comparisons or plots this out for me, or various ways that I could report on that data. So you're saying is that kind of the idea? I end up with this library of scripts that's doing data gathering for me?
Yeah, so I guess take a step back. There's a few ways with there's kind of a few different domains of the network testing. One, it's discovery or information gathering, right? So getting the data from the network. And there's a slew of ways to do that, right? Screen
Mhm.
scraping, we can interrogate some Yang data models. We can call on some, maybe we have tools that already do this, right? There's popular open source tools like CZQ. There's also vendors out there, IP Fabric and Forward Networks, that
Mhm.
provide these mathematical data models of your network. So you can even call on those tools that have already did kind of the heavy lifting for you.
'Cause they'll do discovery, they'll come up with the state of the network and then provide, queryable interfaces so that you can pull that network state out of the database it's already gathered for you. Like, you mentioned Suzy Q. Yeah, we've had Dinesh on to talk about Suzy Q before, and he got into how all it's actually Suzy Q is a whole different topic, but really cool, yeah, and there with the discovery mechanism as a data repository, of your network. You didn't say like Nautilbot or Netbox, would that qualify here as another, dare I say, source of truth, Danny?
Yeah, so that's actually the next piece. So we have the data discovery. We're understanding and discovering the operational state of the network. What is the network actually doing? Not what's in our heads or in design docs, what the network is actually doing, right? So once we get the operational state, that's where we can begin introducing a network source of truth, right? Like a netbox, where we're starting to get what the intended state. What's the network? What should the network look like according to my source of truth, right? And that becomes your expected value, right? So you can do, you can query these discovery tools, which I would recommend building something or buying something to where the discovery and the heavy lifting of getting all that data is done for you. So that way you're not spinning your wheels with Python. But getting all the discovery data and extracting that, and then extracting what your intended state should be from a source of truth, and then doing the comparison. And that in the testing framework piece, which we touched on a little bit about, Cisco PyATS being one of the network testing frameworks out there, but that kind of glues it together, right? We get the pieces from the intended state, the operational state, and then we have a solid testing framework that allows us to do those assertions and validate that it meets our expectation.
Okay, you just had a really important concept you blew through there in about 2 sentences. Intended state, operational state, doing comparison. Intended state, I mean for the network to look like this, and that intended state can be represented a bunch of ways, but we're talking about infrastructure as code in some format or another. That could be JSON. Those could be configuration stanzas carefully laid out in a GitHub repo. It could be I get you can use Netbox that way, I guess. That's possible. And then we want to compare operational state, what the network is actually doing, what is truly happening in real time, the ultimate source of truth. What do the show commands say? What's really happening? And then comparing that intended, the way built my infrastructure as code that is supposed to reflect what the network does compared to what it's actually doing, and then finding the diffs is a massive part of testing here, as you're describing. I'm sorry. It sounds obvious if you're familiar with this world, but if you've not been here before, this is a huge thing.
Absolutely. Yeah, no, that's exactly right. And the best part about this, you may think, "Oh wow, this is exactly what I'd like to see." Maybe run these tests recurring and validate that the intended state meets the operational state. Like I said in the beginning, network testing is one of the least amount of risk um, out there, right? You're just taking values that are defined. We're talking about with tools, but let's say you don't have any tools. You can easily put these in a text file. You can just put them statically in your code, but just starting somewhere and just continually running these tests daily, weekly, so forth, you can quickly have a better understanding of your network than maybe the one person that wrote that design doc 5 years ago, right? Because this doing network testing either validates or invalidates the design documents that everyone kind of reviews when it comes down to troubleshooting, right? Having this actual data to say, well, last week, this one router didn't even have that route. And everyone points to the design doc and says, well, it's supposed to right here. See, you see this policy? And instead of looking at a document, we're doing and we're actually seeing the data as it is, and we're validating it, against what we expect that should be.
I'm laughing a little bit because of the design doc example, in that so often those are just so quickly outdated, or there's subtle changes or tweaks that never got back into whatever the documentation framework is. And there's a couple engineers that know, and they're like, yeah, they can't rely on the doc for that. And then we all move on with our lives and pretend. Yeah, but you're right. You do look at those docs with some expectation that they reflect reality, and so often they don't. And so you've got to do what you're describing. Get right in there and go after what is truth, what is actually reality now. Okay, so we were talking about my daily workflow and bringing testing into it, and you've described intended versus operational state and running tests that validate that or tell me what the diffs are between my intended and my operational state. We don't have to take actions on that, at least not in code, but they may clue me into what's happening. I suppose a more I think mature is the right word. Automation practice maybe would push intended state and pave over whatever the differences are. I know that's ultimately where you want to get to when you're confident enough to be able to do that. You really got to have your operational processes in line for that to not be a risky thing. But I do know there are people that have gotten that far with it. But that's not testing, I guess. I mean, that your point is I can gather all this information, and there's really no risk to me, and I know a lot. I'm made aware of things that maybe I otherwise wouldn't have known.
Yeah, that's a good point. Testing is just one piece of the automation tent, right? We have, your sources of truth that define your intended state. We have configuration management, right? We have tools like Ansible. We have just straight Python code where you can deploy changes to network devices. And then you have kind of your testing and assurance piece, or which kind of blend in with monitoring and observability. They're definitely different, but they complement one another, right? So testing is just one piece of it. But at the end of the day, yeah, I mean, the North Star is being able to deploy all these tools and have them kind of integrated with one another, kind of picking the best in breed for the particular domain. So, like we've talked about Cisco PyATS, there's also a popular just Python framework called PyTest. And so, figuring out what testing framework to use, that's all particular to your network environment. But once you find that particular tool for testing, kind of keep that, get your test developed and incorporate it as part of the bigger picture, which incorporates, like I mentioned, configuration management, network source of truth, and I definitely don't want to forget it, an orchestration layer. Because none of this would be possible without some sort of orchestration platform that kind of weaves all these processes together.
Did you just say pipeline?
Uh, Probably, yeah.
I mean, that's a loaded question to be fair,
Yeah, yeah, yeah,
because
yeah,
yeah,
yeah.
orchestration platform does not invoke pipeline necessarily. And I've
Mhm.
also heard it argued that Tony Burke, I believe, was on. Yes, he was on, and we talked about pipeline for an episode, and he was like, You don't need one unless you really know you need one." And so, if you're asking yourself the question, you probably don't, and because
Yeah.
it's a whole different thing. But to zoom out a little bit, the if I'm pushing a network change and testing becomes part of my testing can become should become part of my process, then automated testing, I mean to say. We've all done changes, and testing's generally speaking all part of what that change is. And you're saying we can advance the art of the change by including before, during, and after testing to in an automated way to know that we've had success or we haven't had success in whatever the change was.
Right. And the one thing, absolutely, I agree with you 100%. And the one thing that also introduces is, to a point you mentioned earlier about, we want to make sure our changes work 100% because we only get this one maintenance window, right? That's the network engineer's mindset of, well, we only get this one maintenance window, so we have to just shove a bunch of changes in here and stay up all night and knock it out over a weekend in a cold data center. Well, what this allows you to do with automated testing is it helps build the confidence of not just your team, but the other teams around you, right? So when the network team comes and says, "Hey, we want to make a change. We're going to run these automated tests before and after and kind of have those results, available." Obviously, not everyone's going to care about number of routes or, hey, this port wasn't up before, the change and now it is. But they will care about, the speed and agility you're able to validate that the network is healthy. And so
Mm,
that's what automated network testing allows you to do. So you're not only helping yourself out, but also increasing the confidence of other teams around you
mm,
in what the network team is doing.
okay. Uh, I would like to talk about information gathering in more details then, because we've kind of hinted around it. Python scripts, and you can do screen scraping, and we've just talked about it broadly. Could you get more detail, Danny, about interfaces I might be hitting on a router or models I might be using to pull structured data back out of a router rather than screen scraping and so on? Where because it's changed a lot over the years. There's been a lot of things have come and gone. Or maybe they never go. They just now we just have this big pile and it's hard to know what to use. What are your thoughts here?
Yeah. So I'll kind of lead off with saying if you have a tool that already does a lot of this or pulls in the data that you're looking for, scrape the tool. Most of the likely their tool has an API that you can hit and collect configs, right? Everyone has a config backup system. Um,
Mhm.
Being able to pull those out of the tool, don't have your script going out and SSH to all these devices individually. Because if you have thousands of devices in your network, you're just causing a bunch of overhead for not just your scripts logic, but just your own sanity. But tooling aside, looking at ways to interface with network devices, I mentioned screen scraping. So using libraries, Python libraries like NetMiko, Napalm, being able to gather the configuration or gathering state data, um, very straightforward. That's NetMiko is where I started, right? So being able to connect to a device and um, collect that output and then parse it. But moving beyond screen scraping and common SSH, we're looking at Yang data models. So
Hmm.
Yang data models live on the network device. So if you're in an environment where you have old and new network devices, and when I say old, like end of life, not support. If you call Cisco, they say what model? Yeah, like those sort of devices. You're not going to have Yang data models on those devices. So a lot of people really do go back to just SSH and screen scraping because least common denominator, is that old device that's in that closet that no one ever visits and no one ever touches it because they don't want it to, power off.
And you might be
Um,
able to pull it out of SNMP, but it's going to be too hard to figure that out.
right, right. You could go down that path as well. But yeah, I would advise against that. So Yang data models is a way, an attempt, I don't know how else to put it, right? Where we can structure, like, basically introduce a structured data model of operational state, but then also the configuration data as well on a network device. You're able to target particular data stores on a network device. So think of running config, your startup config, and then if you're lucky enough, if the device supports a candidate config as well, you can target these particular data stores when that's more around kind of making changes. But the idea there is there are different kind of data stores and ability to extract data. Now, ways to interface with these Yang data models are,
Well,
there's
okay,
NetConf. Yeah, go
before
ahead.
we talk about NetConf and so on,
Yeah.
has Yang truly become ubiquitous at this point?
Um, this based on my experience, I would say no. But I mean, I think that really depends on the environment. I'll give a good example, right? I've at AutoCon, I met someone, and they worked for a telco, and so they heavily utilized Yang data models to make changes across their environment. And there's actually some tooling out there that heavily rely on Yang, such as like Cisco NSO.
Hmm.
So it absolutely is, kind of, a valid answer in some industries and some markets. But if you're, an enterprise that's looking to automate across your network and you have, like I mentioned before, a variety of network devices and ages of network devices, Yang may not be the answer for that.
All right, thank you for letting me take you off track there. I just wanted to qualify that because that's been what you described as kind of my understanding of where we're at with Yang. It sort of depends on the device ecosystem you're in, how well it's supported, whether you get the models you want that have the structured data you're looking for, and the vendor has probably catered to you if you're a big network, a big buyer, and said, "I'm looking for this, I'm looking for that." Okay, we're going to get the model stood up for you, as the case may be. Some of those models are standardized, and some of them aren't. There's the open config Yang model set that seems to be a common denominator, but doesn't make everybody happy for various reasons. Too generic, and in some cases, can't express things the way some people want to express things. Um, but it doesn't, right, it doesn't feel like I can take Yang for granted necessarily. It really depends on, again, the NOS family I'm in, the devices, and then just how well your vendor has chosen to support Yang, probably because someone asked for it.
Yeah, I mean that's a really good way to put it, right? Is it's not that it's not the answer, right? Because there's scenarios where I've used Yang data models to either make changes or especially in the observability space, they're key to pulling observability data out from network devices, right? Monitoring data using tools or protocols like gNMI. I will say you were talking about vendors. Nokia is really, really good with the way they, being 100% compatible with their Yang data models, their CLI. It's
Hmm.
very, very simple to automate against their network devices. So I know it's kind of a free shout out, but Nokia, just based on my experience and what I've seen, they're doing it really well with
Hmm.
Yang.
I work with those guys all the time. I think I'm going to go, hey, why aren't we talking about this? Because they're a wonderful backup push sponsor. We've been talking a lot about SR Linux and their data center products like EDA and so on. Okay, so Yang data models. Then now I had cut you off for that little diversion as you were about to talk about different transports that we might use to retrieve that model data.
Yeah, yeah. So you there's kind of three different protocols, three common protocols with interacting with Yang data models. So you have NetConf, RESTConf, and then gNMI. So NetConf is use it not to go down these each of these, by the way, could totally be their own episode, and I'm sure you've had conversations with others that So to kind of keep it, 10,000 foot view. So NetConf, um, kind of uses SSH under the hood to connect to a device. Um, the really cool part about NetConf is all that you can create atomic transactions. So kind of all or nothing. So
Okay.
let's say you send a big payload, and going back to, I think we talked earlier about like, getting configuration to stick and sending like partial configuration snippets, or I only want part of this config template. Because you have Yang data models, you now have structured data to define what that configuration is going to be without necessarily knowing all the different CLI keywords or commands. So let's say you have a really big payload for a configuration and part of it just doesn't work. Let's say it's rejected or something doesn't work. With the atomic nature of NetConf and the transaction model, it will pull everything out, right? So it won't necessarily, or I'm sorry, it won't pull everything out. The transaction will be incomplete, right? So it just won't stick. So that whole payload it'll basically say, yeah, can't do this because this particular config or this error message. So the netconf and the atomic nature and kind of basically be able to handle transactions is really key there. The other thing I'll mention about netconf is it uses XML. So as far as data encoding, so when you're creating these payloads that I'm talking about, most related to netconf, and that's actually where kind of the RFCs start out is with netconf and XML. So if you ever seen XML, you might say, "Oh my gosh, this is a lot of text." It's very verbose. However, the intent is still there to define, what changes you want to make.
A lot of nesting, a lot of hierarchy in the XML. I mean, it's more designed for that machine to machine communications rather than us looking at it. JSON's way more friendly to my eyes than trying to parse XML if I'm reading it by hand. But you said that, and I immediately thought, yeah, Yang probably loves it because I look at Yang data structures and it does make it's not the same, but it does make me think of XML.
Right. And so that's netconf. The other protocol I mentioned, or the other two, RESTConf and gNMI. So RESTConf actually takes a different approach. So it is following kind of REST principles. So if you ever heard of REST API, kind of there's multiple principles around that framework, but the one important one being stateless, right? So it doesn't really remember its other transactions. So let's say you shoot off a config change, it it works or it doesn't matter to RESTConf. You kind of just send it out there and make the change. Now RESTConf operates over HTTP versus SSH like NetConf, and then it uses JSON. So that way, kind of that readability is there. But like I said, it's to me is if you want to kind of have that going back to NetConf and that transaction safety, I'll call it. That's kind of some perks with NetConf.
Got it. Okay. And NetConf and RESTConf are pretty broadly supported. You might have to turn them on or do some configuration around just getting them enabled, but they tend to be there.
Right, right, and an interesting part with RESTConf is it technically on this network device side, it's technically like a web server, right? Because it's you're doing HTTP, and so to enable it, it's I forget the commands, but you enable RESTConf Yang or RESTConf server, and it turns on basically like an HTTP server on the or process on the box. What circling back to how it's important or what's interesting about it is when there's a security flaw with Cisco devices, and let's say there's an HTTP vulnerability, or hey, there's a HTTP bypass, or you're able to do some injection, and you have to turn off HTTP server on a network device, um, kills off RESTCONF,
Hmm.
right? So many people don't think about that, but let's say you went and you wanted to only manage your network with RESTCONF. If there is some sort of security vulnerability, and as everyone knows, kind of security reigns king when it comes to no, this, security is going to trump you in a war room setting where it's like, no, we have to turn off these settings right now, right? Because we're going to hit this vulnerability, this vulnerability. Um, it can ultimately kind of kill off your management as well if you solely rely on RESTCONF. So
Interesting.
just a little tidbit. I'm not telling you not to use RESTConf, but I've seen that in my experience. So it is an interesting topic versus no one ever shuts off at SSH. Even though there are vulnerabilities with SSH, here and there.
Yeah.
But yeah, just think about it's ever HTTP versus SSH.
Okay, so RESTCONF, NETCONF, and now gNMI. gNMI being it tends to be presented as you were using SNMP. Well, now it's gNMI. I don't know if that's a fair comparison or not. I haven't dug deeply enough into it. It doesn't feel like it's apples to apples exactly, but what do you think?
Yeah, so gNMI, it's definitely more efficient than your RESTConf or NetConf as far as so gNMI you can use as it's based off gRPC, which is Google's RPC framework, and so gNMI is the G doesn't actually stand for Google, and I've looked this up, but the G a lot of people denote the G as standing for Google, but Google's Network Management Interface, so gNMI. Um, and gNMI, based on my experience, I've only really used it in, like you said, replacing your monitoring protocol. So instead of having SNMP, you're now using gNMI. It's more efficient over the wire, right, than SNMP. Definitely more efficient than sending XML and JSON payloads because you actually can send kind of binary streams, right? And so it's
Hmm.
a much more efficient and compact. And there's different modes for gNMI, and like I said, that's a whole conversation in itself. But you're able to query. So gNMI kind of allows you and opens up a world of kind of streaming telemetry. So being able
Right.
to instead of polling the network device, so there's kind of two different modes. You can poll a network device like you do with SNMP. You can do the same with gNMI as well. So you can do what they call dial in to the network device and poll it, or with kind of the concept with streaming telemetry and the big push is instead of polling the device every 5 minutes with SNMP and missing what's between those 5 minute polls, just allow the network device to continually send you data, right? And so being able to send that data via gNMI allows you to get down to the second, if you like,
Yeah.
of data or on change, right, of value changes. So like a good example with that is like BGP neighbors. Like, let's say your BGP neighbor relationships are solid. They're always like you always have six neighbors, and you don't really care to see that number six across the wire every 5 seconds. So you can instruct to say, the device to say, only send me an update if this number changes. So, yeah, it kind of introduces streaming telemetry, and there's a whole, a network observability. There's
Mm.
books on that and other podcasts as well. So I'm not going to go down there, but yeah. So gNMI helps in that situation.
From a testing perspective, it's a little more obvious with NetConf and RESTConf what I'm doing because I'm pulling model data off of the router, that structured data that is telling me things that I need to know about network state. gNMI, it was presented more as I'm listening for data coming off the box. Would I be using that data in my test, perhaps?
You could. So the way I would view it, and to be fair to gNMI, it is still a management interface. I've only ever used it in the monitoring observability, but there are ways that you can. There's tooling such as like gNMIC, to where you can make changes and really manage the device instead of just pulling data. So like I said, I don't want I can't speak out of term there because I've never used it. I've only used it for like that monitoring
Yeah.
observability. Um, but yeah, I mean, what was your question again? Sorry. Going back to
Would gNMI, like RESTConf and NetConf, become a source of data for my network testing?
um yeah, it could. You could process that data within your testing framework, or what I would probably suggest is sending that data off to a database or a tool that can process it, and then you scrape it from that, or interact with that tool's API.
Mm,
So a good example would be, let's say you get all the data into InfluxDB, or a time series database. You could, instead of having that data sent to the box hosting your script, and you have the open ports and whatnot, send it to a time series database where it makes sense within the larger picture, and then have your code query the database. Or let's say you have a visualization tool, such as like um, let's say you have Grafana, right? You could query Grafana for particular data sources, and the data, and at the end of the day, Grafana is querying Influx, right? So you could just shortcut and go to the time series database. But yeah, I would say query a tool and not have the data come directly to you.
okay. Well, Danny, we're coming up on time here, but there's one more big concept I want to draw from your presentation and share here, and that's that's the concept of a testing framework. There's a couple of them that you mentioned in your presentation. You mentioned, and I think you might have mentioned them as we've chatted here, but there's a unit test, and then the one you seem more engaged with was PyTest. Can you talk about what a testing framework is from a Python perspective? What I need to know about it, why I care?
Yeah, yeah. So unit test is baked into the Python standard library, which is, think of it as what comes out of the box with Python. Um, so unit test, and then PyTest, and PyTest is external, so you have to install it. But
Just for clarification here, we talked about unit tests before as a
correct,
concept. This is
yeah,
a Python standard library function called unit test. As you said, it's baked into
correct.
the core of the language offering. Yeah.
Yeah. Yep.
Okay.
Yeah. So, yeah. So unit test has been around forever, and it's baked in, right? So unit test is tried and true. A lot of people used it. PyTest is external, so it's not part of the Python standard library. However, it allows you to create plugins, and it kind of extend the framework. And there's actually one popular plugin that's actually purpose built for network testing called Nuts. It's a PyTest plugin, and so that introduces the ability to kind of augment the framework a bit, the PyTest framework. Um, and so it's gained a lot of popularity amongst developers. And beyond just making a purpose-built plugin for testing, there's plugins for outputs, right? So let's say you want your all your test results to be in a pretty HTML file. You can create a plugin that does that. Now there's some base ones that exist that probably meet your requirements, but you can kind of, it's the world is your oyster with PyTest, because you can kind of build what you need with it.
So the Nuts plugin for PyTest that we're talking about here is a network unit testing system. I found the GitHub repo for it. So
Perfect.
there you
Okay.
go.
Awesome. No, that's yeah, and I definitely recommend checking it out. He said Urs, the work he's put into that, and being able to just kind of put network testing front and center, really appreciate it, and I think it's a great little library.
Okay. There's another concept tied to all of this called fixtures, and I don't know if we have time to get into this or not. If it's too big of a thing, but if you could put it in, if you could compartmentalize, make a simple description of what a fixture is as related to Python testing, PyTest, and maybe nuts, that would be helpful.
Yeah. So fixtures, yeah, it's a concept within PyTest, but the idea is you have a fixture that kind of instantiates an object once, and that you can use it across your tests. So in software development, think of connecting to a database. You don't want to connect to that database multiple times during the test. In networking, maybe you want to connect to all your devices once and then run all your commands and do all your assertions.
I think
Um,
of it as like an object, or there'll be some kind of a handle I can glom onto in the rest of my code once I've done that initial login. There's be some
exactly.
object created that I can reference from there. So kind of like that.
Yep, that's exactly right.
That word fixtures came up a bunch in your presentation, and it was one of those, oh, I haven't heard that before. I kind of got it, but I wanted you just to raise that because it's another one of those like vocabulary places you can stumble if you're trying to get all this into your head. Okay, so testing frameworks. Danny, there's There's so much more that we could talk about, but for sake of time, I think we call it here, man. Um, I guess I do have a concluding question of, is this really worth it? Because if I'm listening to all this, I'm going, oh man, a bunch of new concepts, things I got to do. I got to change my ops workflow. Is there a win here? Is there a big payoff at the end of this? Or is it just like the right thing to do, you know?
Yeah, I mean, that's definitely a loaded question, and a lot of conversation can be had around it. But I mean, in my eyes, I think it's not just the right thing to do, but more importantly, it builds confidence with you, your team, and everyone around you that the network team knows what they're doing when it comes to automation and keeping the network healthy. So ultimately, I think doesn't just doesn't help you, but it helps elevate your team into doing kind of more important things that you're also able to fall back on and say, you know what, our network's fine because of this, these reasons. It's not, you falling back to like we were talking about before, the design doc. Hey, we're good. The design says we're secure, right? Because we implemented,
Right.
802.1x and we implemented these routing authentication, methods. No, if you're able to validate the operating state of the network, meeting the standards you outlined in that design doc and doing on a recurring basis, I think that allows your team to kind of sleep better at night, but then also allow you to kind of evolve and move on to bigger and better things.
Well, you kind of summed it up as perpetual auditing, that you'd be very confident, as opposed to quarterly or whatever auditing that you hate doing because you know the auditor is going to come up and find this, that, and the other thing you got to fix. You know every day you're in good shape if you've once you've got this to a mature practice standpoint and can just iterate on it daily as needed to know everything's right in compliance and where you want it to be. And to plug your presentation that is on the YouTube Network Automation Forum channel from AutoCon 2, you closed your presentation with several lengthy examples of wins that different organizations had as they implemented network testing and got into some good detail about it. So if you're listening to this and you want more meat on the bones of why you should do this, go watch Danny's presentation there, and we'll link to it in the show notes for you. Well, Danny, how do people find you on the internet? I know you got a blog, you're on LinkedIn. Tell people where they can find you.
Yeah, so I'm on LinkedIn. Sure, my handle on there is like Daniel C. Wade. It's just my
It
full
is.
name.
Yep.
Yeah.
Daniel C. Wade.
Okay.
Yep.
um, my blog is DevNetDan. That's also my Twitter handle as well. So devnetdan.com or message me on Twitter.
Very good. And of course, Danny is the co-author of Cisco PyATS Network Test and Automation Solution, the subtext of data-driven and reusable testing for modern networks. That's a mouthful, but it's a Cisco press book. Dan Wade and John Capobianco are the authors. Go pick yourself up a copy. And thank you for listening to Heavy Networking today. About the book. I'm a book author myself. I will tell you that we who write these tech books, we don't make much writing them. So if Danny's book is interesting, go pick up a copy. Danny and John are going to make a little coffee money. They will really appreciate it. These books like this are really hard to write. They take a lot of time, and show your appreciation for the knowledge Danny shared on the show by picking up a copy of the book. That'd be a great thing. Now, if you've got questions or comments about the conversation Danny and I had, or maybe you got a topic request, something else you want to hear on heavy networking, send that to us via packetpushers.net/follow-up. And you can also please join our community Slack, sign up for our free newsletters that don't suck, buy some merch at store.packetpushers.net. You can subscribe to all the things. You could leave comments on Spotify, Apple, YouTube, and everywhere else, and tell your friends. We'd really appreciate all of those things as we try to keep the Packet Pushers train rolling down the tracks in what is sure to be an interesting year in the global economy as we record this here in April 2025. Last but not least, remember that too much networking would never be enough.